Hi guys, as part of today's lecture, I will be introducing to you the Lux Meter project and the algorithm behind it. As part of today's lecture, we will first look at how to read an input value, and then in the second half of the lecture, we will look at the calibration of the Lux Meter and the algorithm behind the calibration that we'll be doing. So let us look at first the basics of the Lux Meter project. So as you know that this is your board, and in the previous analog interfaces lecture, you had interfaced a potentiometer with one terminal going to ground and the other one going to VDD. In this particular project, we will be replacing the potentiometer with the LDR on your interface board, which has an LDR, which is a light dependent resistor. Now we know that with the LDR, the voltage drop or the resistance of the LDR will change depending on the light intensity. So once the resistance changes, if you apply a voltage, then the voltage drop across this resistance will change. So we are aware of that. So we will be measuring the change in voltage drop across this LDR. So you have an LDR pin on your interface board, and you will be connecting that to your analog interface. So the first part of the lab is similar to the potentiometer LCD interface lab that I explained in the analog basics lecture. So it's just that you will replace the potentiometer with the LDR interface. So the first part is interfacing the LDR and measuring the change in voltage, as you change the light falling on it. So first you need to do that. Once you know that as per change in light, if you get a change in voltage, your step 1 is done. Step number 2, you have to understand how this voltage that you are measuring can actually be converted into lux, which will be used to measure the light intensity in a more standardized way. So this is the tricky part in this project. This is fairly straightforward. If you replace your potentiometer with the LDR interface, you should be fine. And then you can measure it and display the voltage. Now this is the part that we need to understand. So to design a lux meter where now you have that voltage and you need to convert it into lux, first I would encourage all those with an Android phone to download a Lux Meter app. There's an app called as Lux Meter. So we will be using this app to calibrate our Lux Meter project. Now, why do you need calibration? We have to make sure that our lux meter is at least giving values or giving lux values which are close to commercially available solutions. Alright, this is our aim. So we will make sure that our Lux Meter app, or our project, I'm sorry, will at least be close to this Lux Meter app which is available on the Android marketplace. So I would first suggest you all to download this Android app which is called Lux Meter. So now that you're done, here is what we'll do. First, place your mobile phone with the Lux Meter app running and place your interface board with the LDR already connected to your mbed board, and you have your LCD. Make sure that the sensor of your phone and your LDR are close to each other, and what you need to do is vary the intensity of light on this region here and measure the lux reading and the voltage on the LCD. So you say L1 V1. So for one particular intensity of light, let me say case 1, you will get one lux meter reading and one voltage reading. Then you change the intensity of light again for case 2. So you will get L2, you would get V2, and so on and so forth. Make sure that you have variations. For example, case 1 would be full darkness and case 10 would be full brightness. Maybe you can use the flash of another cell phone as an input. Now make sure that you have at least 10 data points. You have at least 10 data points or 10 cases where you have one lux meter reading and its corresponding voltage, another lux meter reading and its corresponding voltage. So that ways you will have a table V1, L1, V2, L2, V10, L10. So now we know what each voltage which is from our LDR actually means in terms of actual lux meter readings. So we already know that. However, we only have certain spaced out data points. If you look at it from a graphical perspective, if I say this is L, which is your lux, and this is V, which is your voltage, as your lux increases or light increases, you will observe that your voltage actually falls down. So you have data points, let's say, which is V1, L1, then you will have V2, L2, then V3, L3, and so on and so forth. For correctness sake, I am eliminating this curve, so we just have data points right now, which is V1, L1, V2, L2, V3, L3. So now comes the important step where suppose I want to convert any given voltage which I will get from my LDR into a lux reading. So let's say you have again V1 L1, V2 L2, V3 L3, and so on and so forth. So now given any V, any given V, which is my LDR reading, I would like to find out what is my corresponding L. One way would be to do something called as curve fitting, but to do that in real time using a microcontroller will take a lot of time. So this solution does not work. So what we would have to do is we do something called as linear interpolation, where we say that between each of these data points you assume there is a straight line. So let's say, for example, you get a voltage V, let's call it VR, which is somewhere in between here, and we have to find out what is the corresponding L. So what we say is that if VR is between V1 and V2, then it will be on the straight line between V1 L1 and V2 L2. So I can use a mathematical function, as we all know, to find the slope. I can find the slope of this line by saying slope is equal to L2 minus L1 upon V2 minus V1, or you can also say V2 minus V1 upon L2 minus L1. So I can find the slope, and once I find the slope m, I can say that m is now equal to VR minus V1 upon LR minus L1. I've just used a linear, this is called as linear interpolation, where I assume that it's a straight line. I'm using a process called as linear interpolation, where I am assuming that this is a straight line, and once I get the slope, I can now replace, we know that the slope will be same as long as the data point is on the straight line. And so now that I know the value of VR, I know the value of V1, I know the value of M, I know the value of L1, I can easily find out the value LR, which is my actual lux value which I want. So if I view this from a tabular perspective, I have L1, V1, L2, V2, L3, V3, L4, V4, L5, V5. I'm just taking this example with 5 data points. Once you can understand with 5, you will definitely be able to do it up till 10. So what we'll do here is, let's say we find our value VR from our LDR. So this will be from your analog input, your analog in. Now we find out VR. We keep searching whether VR is between V1 and V2, between V2 and V3, between V3 and V4, or between V4 and V5. Let's say it is between V4 and V5. It could be equal to V4 and V5 as well, so make sure you take care of the equal to sign as well. So let's say it is in this range here, Now I assume that there is a straight line between these two data points, which is V4 L4 and V5 L5, and I find the slope m is equal to V4 minus V5 upon L4 minus L5. That gives me the slope. Once I get the slope m, then I can find out my LR, which is here, since we found VR here. Now that you found the slope, you can now rearrange this equation such that m is equal to VR minus V5 upon LR minus L5. So we know the value of m, we know VR, we know V5, and we know L5. So then you can go ahead and find out LR, which is your lux meter value. So this is the general algorithm for finding out the lux value corresponding to the LDR. Now just a quick revision, we got these data points by comparing our lux meter values with the Lux Meter Android app, and we took different cases of light and we exposed the sensor and the LDR to that light and created different cases. So for each case we noted down the Lux Meter app reading and the corresponding voltage reading on the LCD and created a table which measured the different values, and then depending on the VR value we found out which range the VR value was in, and then we found the slope, and then we applied simple linear interpolation to find out LR. A few hints: the finding this value in a range, in this range, for the program you might want to think in terms of a while or a for loop for searching in this. Rest all is quite straightforward. You should be able to handle this. So I hope this is clear about the algorithm. On your LCD you might want to display voltage is equal to so and so, lux is equal to so and so, so that it will look neat once you get the application, and then you can compare it to the Android app as well to show that it's almost similar values. That should be the end goal of your project. So I hope this lecture is clear in terms of understanding the algorithm. Thank you.